Welcome back, children. Last time we discussed Pythagoras theorem and some of the questions of the exercise. I'll discuss some more questions in this video. Now I'll be discussing some proving questions with you. The first question that we have is, in the given figure, ABC is a right triangle. Right angle at C. C is right angle. If D is the midpoint of BC, this D is midpoint of BC, means BD is equal to DC. Prove that AB square is equal to 4AD square minus 3AC square. First, what is given? Let us write that. It is given D is midpoint of BC. When D is midpoint of BC, this BD is equal to DC equal to half of BC. This we already know. Or we can write it as BC is equal to twice of DC or twice of BD. We can write in any of these forms. Now, how do you solve proving questions? Just find out LHS or RHS. Here I am taking LHS. LHS is AB square. How can I find AB square? In this figure, I can find AB square by applying Pythagoras theorem in triangle ABC. So I will apply Pythagoras theorem in triangle ABC. In triangle ABC, if I apply Pythagoras theorem, I will get AB square, hypotenuse square, is equal to AC square plus BC square. This I have got. Now compare what you needed and what you have got. AB square I have got. AD I have not got. AC is present. Ignore 3 right now. AC is present. So leave these two and see how can we change the third one. What do we know about third term? BC square. What do we know about BC? We know that BC is equal to twice of DC and twice of BD also. Which of the two will be useful to us? BD is not included in any right triangle, but this DC is included in a right triangle. And this right triangle contains AD also, which we need. So I will write BC as twice of DC because it is concluded in triangle which includes AD. So I have written as twice of DC whole square. Let's open it. I get AB square is equal to AC square plus square of 2, 4 DC square. Now I have got AB and AC. Still AD is missing. Can I write DC in terms of AD? Yes, I can write. How? If I apply Pythagoras theorem in triangle ADC, Pythagoras theorem in triangle ADC, what do I get? AD square is equal to DC square plus AC square. From here, DC square is equal to AD square minus AC square, taking AC to this left hand side. So I have written DC as AD minus AC. AD square minus AC square. So AB square is equal to AC square plus 4AD square minus 4AC square. AB square is equal to AC minus 4AC is minus 3AC square plus 4AD square. AB square, this can be written as 4AD square minus 3AD square. This and this is one and the same thing, and this is what we needed. So hence proved. First I formed a relation between BC and DC because DC was included in the triangle which contained AD that we needed. And then we have formed a relation. This you have to write as a reason that why you have written DC as AD square minus AC square. See another question. In a rhombus, if diagonals are 30 cm and 40 cm, find its perimeter. I have drawn a rhombus here, ABCD, and two diagonals also. This is 40 cm and this is 30 cm. And they are meeting at point O. Now we have to find the perimeter. For finding the perimeter of a rhombus, I need all the sides. Perimeter, all sides of rhombus are equal. So perimeter of a rhombus is equal to 4 into side. If I find side by any means, then I'll be able to find the perimeter. Now I know one important property of rhombus, that is diagonals of rhombus bisect each other at 90 degree. Now since diagonals of rhombus bisect each other at 90 degree, this angle BOC is 90 degree. All these angles will be 90. I am considering this right now. Triangle BOC will be 90 degree. Also, because the diagonals bisect each other, this side and this side are equal. OA is equal to OC and this side and this side are equal. OD is equal to OB. So OC is equal to, and also this will be half of AC because it is being bisected. Diagonal has been bisected. That is 20 cm and OB is equal to half of BD, that is equal to 15 centimeter. Now, since this angle is 90 degree, I can apply Pythagoras theorem in this triangle, and with the help of that Pythagoras theorem, I can find BC. So I will apply Pythagoras theorem in triangle OBC. In triangle OBC, by Pythagoras theorem, hypotenuse will be BC. OBC square will be equal to OB square plus OC square, that is equal to OB is 15 and OC is 20. 15 square plus 20 square, that is 225 plus 400, that is equal to 625. And BC will be equal to under root 625, that is equal to 25 centimeter. Side of rhombus is 25 centimeter. And what is perimeter of a rhombus? 4 into side, that is 4 into 25 is equal to 100 centimeter. And property that you need to remember is diagonals of rhombus bisect each other at 90 degree. Let us see one more question. In the given figure, D and E are midpoints of sides BC and CA. This D is midpoint of side BC. This is C. And this E is midpoint of side CA. What we have to prove is right angle. See, this is right angle. We are supposed to prove is 4AD square is equal to 4AC square plus 4BC square. Consider first part only right now. What do I need? AD square. Ignore 4 for now. I need AD square. So I'll just go with LHS first and I'll find AD square. I can find AD square. This is AD. I can find AD square using this triangle ACD. So I will apply Pythagoras theorem in triangle ACD. In triangle ACD by Pythagoras theorem, what do I get? AD square is equal to AC square plus CD square. AC square plus CD square I have got. Now let us compare what we have got. AD I needed, AD I have got. AC I needed, AC I have got, yes. BC, and here it is CD. Do I need CD? No. I need BC in place of that. So let us see, is there any relation between BC and CD? Is there any relation between BC and CD? Yes. What is the relation? We know D is midpoint of BC. So what is the relation? CD is equal to half of BC. Because this is midpoint, so this will be half of BC. So CD is equal to half of BC. Reason, D is midpoint of BC. Now let us open it. We get AD square is equal to AC square plus BC square upon 4. AD square is equal to, I'll take LCM now. 4AC square plus BC square upon 4. Why I have taken LCM? Because I needed 4AC square. On transposing it to left hand side, I get 4AD square is equal to 4AC square plus BC square. Hence proved. This is the result that was needed. See second part. 4BE square is equal to 4BC square plus AC square. Now again I need BE. Let us see the triangle which contains BE. This BE is contained in triangle this BEC or ECB. So I will apply Pythagoras theorem in this triangle. In triangle ECB by Pythagoras theorem, what can I write? BE square is equal to, this BE square is equal to BC square plus EC square, BC square plus CE square by Pythagoras theorem. So again see what we have got. I needed BE, I have got BE. I needed BC, I have got BC. I need AC, have I got? No, I have got CE. Is there any relation between AC and CE? Yes, there is a relation. Again, same type of relation that was formed in first part. This E is midpoint, so these two sides will be equal and each will be equal to half of AC. So I can write CE as half of AC. BE square is equal to BC square plus AC square upon 4. Again, in the same way, right, step yourself. In the same way, taking LCM, I will get 4BE square is equal to 4BC square plus AC square. Hence proved. Last part, third part. 4AD square plus B square is equal to 5AB square. This is what we have to prove. Just see these two and this left hand side. Anything common? Yes. If I add these two, I will get this left hand side. If I add these two, I will get this left hand side. See what we can do with right hand side. First we will add these two. Mark the result we have got from first equation as 1 and the result which we have got from second equation as 2. and we'll add these two values, these two equations, sorry. On adding these two equations, what we are getting? Adding 1 and 2. On adding 1 and 2, what we have got? 4AD square is equal to 4AC square plus BC square. 4BE square is equal to 4BC square plus AC square. These were the two equations. On adding these, I get 4 common. AD square plus BE square is equal to 4AC plus AC is equal to 5AC square. BC plus 4BC is equal to 5BC square. Now this will be copied as it is. On right hand side, 5 is common. AC square plus BC square. But was it that was needed? Is it what was needed? No. I needed AB square. Can I write AB square in this form? Is it equal to AB square? Yes. From the given figure, if I apply Pythagoras theorem in this complete triangle ABC, there is a complete triangle is given ABC. From this triangle, I can write by Pythagoras theorem AB square is equal to AC square plus BC square. So AC square plus BC square is equal to AB square by Pythagoras theorem. Thus we have reached the result which we wanted, that is 4 into AD square plus BE square is equal to 5AB square. Hence proved. Let us see one more question. In a quadrilateral ABCD, angle B is 90 degree is equal to angle D. Two angles are 90 degree. Prove that twice of AC square minus BC square is equal to AB plus AD plus DC square of all three sides. I have drawn the quadrilateral here. Angle B is 90 degree and angle D is also 90 degree, and since AC we have to take, I have drawn this diagonal AC also. Now I need AC square. I can find it by Pythagoras theorem, and there are two triangles in which I can apply Pythagoras theorem. One is triangle ABC and another one is triangle ADC. I can apply Pythagoras theorem in any one of these two. If I apply Pythagoras theorem in this triangle ABC, let me see what we can get. I will get AC square is equal to AB square plus BC square. AB, BC, AC all are present, but not those two are not present. These two can come from this triangle ADC. So I'll find AC square with the help of these two now. Why I'm finding AC square again? I need 2AC square here. So I'll get one more AC square also, and these two also I will get. So I will apply now in triangle ADC by Pythagoras theorem. AC square is equal to AD square plus DC square. AD square plus DC square. I have got AC from these two triangles. Mark it 1, mark it 2, because I need 2 AC square. If I add these two values, I will get AC square, and I have got the remaining terms also. On adding 1 and 2, what I get? AC square plus AC square, 2AC square, and all these will be written AB square plus BC square plus AD square plus DC square. What I have got now? Twice of AC was needed. What was needed? I have got that. AB was needed, AB I have got. AD was needed, AD I have got. DC was needed, DC I have got. But BC was not required on right hand side. It is required on left hand side. If I transpose it to left hand side, it will become minus BC square. So just transpose it to left hand side, and this is the result that was needed. So I have reached what was asked, hence proved. Let us see one more question. In triangle ABC, angle A is 90 degree. I have drawn the triangle here. ABC is a triangle in which angle A is 90 degree. And D is a point on AB produced. Prove that D is a point on AB produced. We have produced AB forward, and D is a point on this side AB produced. Also CA is equal to AB, means these two sides are equal. What we have to prove is DC square minus BD square is equal to twice of AB into AD. LHS contains DC square minus BD square. So I'll find DC and I'll find BD, and then I'll see what we can write. I'll find DC first. DC square. I can find DC square by applying Pythagoras theorem in this complete triangle ADC. So in triangle ADC by Pythagoras theorem, DC square, this is hypotenuse, is equal to AD square plus AC square. This I can write. Now let us see what we have got. I have got DC. DC was needed. I have got it. AB, AD. Nothing we have got. We have not got BD also. But what can I write? Let us see. This AD. Is there any way with the help of these I can find AB, AD and BD? With the help of this AD, I can write BD because AD contains BD. So I will split AD into AB and BD. DC square is equal to AC square plus this AC square plus AD can be written as AB plus BD. Why I am writing this? Because if I write it as AB and BD, I will get both AB and BD that are needed in proving this equality that the question is asking. So DC square is equal to AC square plus AB plus BD whole square. Now this AB plus BD whole square we can expand by using A plus B whole square formula. So DC square is equal to AC square. This will be AB square plus BD square plus twice of AB into BD. This is what we have got. Now this BD square is needed on left hand side. So I will transpose it to left hand side. DC square minus BD square is equal to AC square plus AB square plus twice of AB into BD. I have got LHS. In RHS I have got AB. But I do not need this BD. In place of BD, AD is needed and these two are also not needed. See what can I write. What was given to us, that information we'll see. AC and AB are equal. So in place of AC, I can write AB. At least one term will be removed. Let us see what will be written. I can write AC as AB. AB square plus twice of AB into BD. This is twice of AB square plus twice of AB into BD. Why I have done it? Now in these two, AB will be common. And AB is needed also. So that's why I have removed AC and written AB because AB is needed. So twice of AB is common. What will be left when AB is taken? LHS is copied as it is. AB is taken common. What is left here? Out of AB square, AB is common. So what is left? AB plus, here twice of AB was out. What is left? BD. AB plus BD. And what is AB plus BD? This is equal to AD. So in place of AB plus BD, I can write AD. DC square minus BD square is equal to twice of AB into AD. And this was the result that was needed. Hence proved. Start with DC. With the help of DC, I have reached to BD also, AB, AD also. Just keep on writing the information using the information that is given in question. With this, we have completed the chapter Pythagoras Theorem. You can do the remaining questions of the exercise and these questions, practice these questions. Till now, we'll meet next time with next chapter.